Bismillahirrahmanirrahim. Starting with the name of Allah, the most beneficent and the most merciful. My name is Malaika and I'm in the Department of BS Chemistry. Today in my presentation, I'm going to discuss a very important topic relative to textile industry, which is dyes, and in dyes specifically indigo dye. Indigo dye is a member of white dye family, and the white dyes are explained by me in the previous presentation extensively. So, indigo dye is an organic compound with a distinctive blue color. Historically, indigo was a natural dye which is extracted from the leaves of some plants like Indigofera genus and in particularly Indigofera tinctoria. And these plants were commonly grown and used throughout the world, in Asia in particular as an important crop, with the production of indigo dyestuff economically important due to the previous rarity of some blue dyestuffs historically. So most indigo dye produced today is synthetic, constituting several thousand tons each year. It is most commonly associated with the production of denim cloth and blue jeans, where its properties allow for effects such as stone washing and acid washing to be applied quickly. Now talking about some of its uses. So as it's clear from its name that the primary use for the indigo dye is a dye for cotton yarn, mainly used in the production of denim cloth suitable for blue jeans. And on average, a pair of blue jeans requires just 3 grams to 12 grams of dye, and smaller quantities are used in the dyeing of wool and silk. And secondly, we have a indigo carmine, which is an indigo derivative which is used as a colorant, and about 20,000 tons are produced annually, again mainly for the production of blue jeans. It is also used as a food colorant and is listed in the United States as FTNC Blue number 2. Talking about some of the more sources of indigo. So, a variety of plants have provided indigo throughout history, but most natural indigo was obtained from those in the genus Indigofera, which are native to the tropics, notably the Indian subcontinent. The primary commercial indigo species in Asia was true indigo, Indigofera tinctoria. A common alternative used in the relatively colder subtropical locations such as Japan and Taiwan is Strobilanthes guicia. Before Indigofera species from the south, Polygonum tinctorum was the most important blue dyestuff in East Asia. However, the crop produces less dyestuff than the average crop of indigo, so that's why it was quickly surpassed in terms of favor for the more economical Indigofera tinctoria plant. The precursor to indigo is indican, basically, which is a colorless, water-soluble derivative of the amino acid tryptophan. Indican is naturally present in the indigo plant, indigo tinctorial plant. Indican then hydrolyzes to release beta D glucose and indoxyl, and then the indoxyl is oxidized by air oxidation process, and it converts to indigotin, which is the insoluble blue chemical that is the end point of indigo dye. Indican was obtained from the processing of the plant leaves, which contain as much as 0.2 to 0.8% of this compound. The leaves were soaked in water and they were fermented to convert the glycoside indican present in the plant to the blue dye indigotin, and this process is explained by the chemical synthesis formula. As you can see that the indican, which is a water-soluble derivative of amino acid, it first hydrolyzes in the presence of NaOH to release beta-D-glucose and indoxyl, and then this indoxyl is oxidized and carbon dioxide is released from it, and it gives us the required indigo. Now we'll have a look at some of the short history of the indigo. So the oldest known fabric dyed indigo, dated to 6,000 years ago, was discovered in Huaca Preta. Asian countries such as India, Japan, Southeast Asian nations have used indigo as a dye for centuries. India was a primary supplier of indigo to Europe as early as the Greco-Roman era, and the association of indigo with indigo is reflected in the Greek word for the dye, which is indikon, which means India. And then the Romans Latinized the term to indicum, which passed into Italian dialect and eventually into English as the word indigo. In Japan, basically, indigo becomes especially important when the commoners had been banned from wearing silk, leading to the increasing cultivation of cotton. And this increased cultivation of cotton leads to the use of indigo, because indigo was one of the few substances that could dye it. And Newton used indigo to describe one of the two new primary colors he added to the five he had originally named in his revised account of the rainbow in Lectiones Optica of 1675. Now we'll discuss the dyeing technology using indigo or indigo white. So indigo is a challenging dye because it is not soluble in water, as like the vat dye, because it's a member of vat dye. To be dissolved, it must undergo a chemical change, means reduction, and reduction converts indigo into its white indigo, which is a leucoform or soluble form. So when a submerged fabric is removed from the dye bath, the white indigo quickly combines with oxygen in the air and reverts to the insoluble, intensely colored indigo. Basically, when it first became widely available in Europe in the 16th century, then European dyers and printers struggled with indigo because of this distinctive property. It also required several chemical manipulations, some involving toxic materials, and had many opportunities to injure workers. In the 19th century, English poet William Wordsworth referred to the plight of indigo dye workers to his hometown of Cockermouth in his autobiographical poem. And speaking of their dire working conditions and the empathy that he felt for them, he wrote that doubtless I should have made common cause with some who perished, happily perished too, a poor, mistaken, and bewildered offering, unknown to those bare souls of Miller Blue. So, now how we can print or apply the vat dye on the fabric. So there are two different methods for the direct application of indigo, and they were developed in England. The first method is pencil blue because it is most often applied by a pencil or brush and could be used to achieve dark hues. Arsenic trisulfide and a thickener is added to the indigo vat in this process because the arsenic compound can delay the oxidation of the indigo long enough to paint the dye onto fabric. And its second method is China blue, and it's so named because it is resembled to Chinese blue and white proclaim. So in this method, instead of using an indigo solution directly, the process involves printing the insoluble form of indigo dye onto the fabric. The indigo was then reduced in a sequence of baths of iron sulfate with their oxidation between each immersion. The China blue process could make sharp designs, but it could not produce the dark hues possible with the pencil blue method. Talking about some of the chemical properties of indigo dye, so it is a dark blue crystalline powder that sublimes at 392 degrees C. It is insoluble in water, alcohol or ether, but soluble in DMSO, chloroform, nitrobenzene, and concentrated sulfuric acid. The chemical formula of indigo is C16H10N2O2. This molecule absorbs light in the orange spiral spectrum, wavelength of 630 nanometer. This compound owes its deep color to the conjugation of the double bonds. The double bonds within the molecules are adjacent and the molecule is planar. In indigo white, the conjugation is interrupted because the molecule is nonpolar. There is a very interesting application of indigo as an organic semiconductor. So, indigo and some of its derivatives are known to be ambipolar organic semiconductors when deposited as thin film by vacuum evaporation. That's all from my side. Thank you.